NASA's Voyager 1 is the most distant object humanity has ever launched into space. Since its launch in 1977, this spacecraft, along with its twin, Voyager 2, has traveled farther than anyone ever imagined possible. It began as part of a bold mission to explore the outer planets, but over the decades, it has transformed into something much more profound: a silent messenger drifting into the vastness of interstellar space. Voyager 1's original task was simple but ambitious. It was to perform close flybys of Jupiter and Saturn, collecting detailed data and images never seen before. And it did just that. In 1979, it gave us the first close-up views of Jupiter's raging Great Red Spot and its volcanic moon, Io. Then in 1980, it passed Saturn, revealing the intricate structure of its rings and the hazy atmosphere of its giant moon, Titan. But what came next wasn't just a continuation of the mission. It was the beginning of something no spacecraft had ever done. After completing its planetary tour, Voyager 1 continued outward. In 2012, it achieved a milestone no other human-made object had reached. It crossed the heliopause, the boundary where the sun's influence ends, and officially entered interstellar space. This moment was monumental. For the first time, a spacecraft was directly sampling the environment between the stars. Out there, Voyager began to detect strange and unexpected phenomena. The density of plasma was higher than expected. The magnetic fields behaved differently. Cosmic rays, those high-energy particles that zip through the galaxy, were suddenly more intense. The spacecraft had left the protective bubble of the solar system and entered a realm shaped by the distant deaths of stars, by ancient supernovae, and by forces we are only beginning to understand. Meanwhile, Voyager 2, traveling on a slightly different path, continued its own extraordinary journey. It became the only spacecraft in history to fly past Uranus and Neptune. Voyager 2 revealed Uranus's mysterious tilted axis and discovered a surprisingly dynamic Neptune, with winds faster than any recorded on Earth. These encounters radically reshaped our understanding of the outer solar system. Today, Voyager 1 is more than 14.6 billion kilometers from Earth. Its signal takes over 22 hours to reach us, even at the speed of light. Yet, thanks to NASA's Deep Space Network, equipped with massive dish antennas, we still receive that signal. It's faint, incredibly faint. The transmitter on Voyager only puts out about 20 watts, roughly the power of a refrigerator light bulb. But that tiny whisper, traveling across the darkness of space, still reaches us. The spacecraft itself is a marvel of engineering. Designed in the 1970s, it runs on 3 radioisotope thermoelectric generators, nuclear batteries that convert heat into electricity. They're slowly losing power, and now generate just under 300 watts, barely enough to power a few household bulbs. To conserve energy, engineers have gradually turned off non-essential systems and even some scientific instruments. But Voyager keeps going. Its systems are remarkably resilient. It uses ancient computer chips with less processing power than a basic calculator, yet those chips control a complex dance of communication, navigation, and scientific data collection. When the main thrusters began to degrade after decades of use, NASA engineers switched to backup thrusters that hadn't been used since the late 1970s, and they worked flawlessly. Navigating a spacecraft through the outer solar system is no simple feat. Engineers used a technique called gravity assist, using the momentum of planets like Jupiter and Saturn to slingshot Voyager faster and farther than any rocket alone could achieve. This not only saved fuel but propelled Voyager to the edge of the solar system and beyond. The trajectory had to be calculated with mind-boggling precision, accounting for gravitational pulls, solar radiation, and the spacecraft's slow drift through space. Now, in interstellar space, Voyager 1 continues to collect and transmit data. It's helping scientists understand the true nature of the space between stars, the density, the magnetic fields, the particle environment. We've learned that the heliosphere isn't a perfect sphere, but rather a distorted, shifting boundary, affected by outside pressure from the galactic environment. And yet, time is catching up. Every year, its power supply diminishes. Engineers estimate that around 2025 to 2026, the last of the instruments will be shut down. Eventually, Voyager 1 will fall silent. Its antenna will stop transmitting. But it will continue on its journey, silently coasting through space at over 61,000 kilometers per hour, possibly for millions of years. Long after its signal fades, Voyager will still be out there, a lonely traveler carrying the golden record, a time capsule of Earth. It contains greetings in 55 languages, music from cultures across the globe, natural sounds like waves and thunder, and even encoded images of life on Earth. It's our attempt to say, we were here. This is who we were. Voyager is more than a machine, it's a symbol. A symbol of what humans can achieve when we reach beyond our limitations. Of how curiosity, vision, and courage can send a tiny spacecraft across the vast sea of stars. It reminds us of our place in the cosmos. Small, fragile, and yet, capable of greatness.